Did you ever find yourself browsing the internet one day playing a game where you try to go from one Wikipedia article to another random Wikipedia article and seeing how many clicks it took you to get there? This game, which is branded as the Wikipedia game, is what we're implementing basically right here into this new DSA project by the name of WikiLeakz. And so WikiLeakz takes this exact childhood memory and it basically builds a fully functional, full stack, live website to make it a reality. And so using the power of JavaScript, Python, HTML, and CSS, we take a desired starting page and an ending page, a target page right here, and we calculate the variety of different paths from one to the other, and we take the graph that is outputted as a result of that, and we only output to the user the connected graph that connects the starting page to the target page. So let's go ahead and load up an example here. We're going to take pizza as our starting page, and then we're going to go for wheat as our ending page. And so we're going to go ahead and generate that there. So using the Flask Python library, we're able to scrape live Wikipedia articles and iterate through different possible paths using depth first search and breadth first search to produce the connected graph. This approach saves us a lot of money and resources in computation, as well as terabytes in space. Because as you may know, the Wikipedia set itself is terabytes in size. So at the same time, while we're able to avoid that expensive resource-heavy cost, we're still able to maintain the millions and millions of potential vertices that are provided to us in the form of Wikipedia articles. And so as you can see right here, the graph from horse to evolution was from wheat to pizza was just outputted here. So if you hover over each of these nodes, you can see what each of them actually represent. So here at the left edge of things, we have the wheat node, and then if we look for our pizza node, here it is right here, you can see the different possible paths that you can take from one to the other to get to your desired node. And so once again, we're scraping live Wikipedia articles using Flask. And to be clear, anybody can actually visit this website. So as long as you just type in the above URL right here, you can go ahead and try this out for yourself. And just to get a quick snippet of the actual code behind the scenes, we have the front end stuff right here, as well as the Python backend that iterates through and actually implements DFS and BFS to generate the graph. And so this is all right there. And that's about it, really. I mean, you can go ahead and try this website out for yourself. Here at the bottom left, you have the article of the day, which is just a fun little side thing that we added for the users to see while they wait for their graph to be implemented and whatnot. And as far as the libraries that we use to actually generate this graph, we're using the D3 JavaScript library, which provides us this sort of like force simulation right here, where you can kind of click and drag each node in a very fun way to move them around and rearrange them in different ways on the page. So once again, this is uploaded through Heroku. As you can tell by the top of the page, we deployed our app there so that anybody can use the web app itself. And that's about it for this project. I hope you guys enjoy, and you can go ahead and try it out for yourself if you wish.